Alright, so in this video we're going to be going through a percentage yield problem like question 4 in assignment 17. So the question is, 1 mole of O2 produces 2 moles of H2O. If the percentage yield is 82%, how many grams of O2 do you need to start with to get 500 grams of H2O? So normally we would need to start with a balanced chemical reaction, but we don't in this case because we actually have the mole ratio given to us in the problem. So it's 1 mole of O2 to 2 moles of H2O. I'm just going to write that here. All right. So some other important information from the question includes the percentage yield for the reaction and the amount of H2O that we want to end up with. So for this question, we are going to need to get the molar mass of O2 and the molar mass of H2O. So the molar mass of H2O equals the molar mass of hydrogen times 2 plus the molar mass of oxygen. That equals 1.008 grams per mole times 2 plus 16 grams per mole, giving us a molar mass of 18.016 grams per mole for H2O. And the molar mass for oxygen is the molar mass of an oxygen atom times 2, that's 16 grams per mole times 2, giving us 32 grams per mole. All right. So there's a couple of ways you can approach this problem. What I'm going to do is start with the mass of water. I want to convert that into grams. So the mass of water that I want to reach is 500 grams, and I want to figure out how many moles that is. So the number of moles of H2O equals 500 grams of H2O, and that would be divided by the molar mass, which is 18.016 grams per mole. And that is going to give us a value of 27.75 moles. Of H2O. So that's what we're aiming to have produced in this question. The other trick here is that the percentage yield for this reaction is not 100%, it's only 82%. So if we're looking for the number of grams of oxygen that we need to react, we know that we're going to need enough to account for that 82% percentage yield. So you can do this one of two ways. One, you can use the molar ratio to find the amount of oxygen you need first in moles, and then divide by the percentage yield. Or you can divide by the percentage yield first, and then find the number of moles of oxygen you need. It doesn't matter which you do first, you'll get the same answer. So I'm going to convert to moles of oxygen first. All right, so we have 27.75 moles of H2O we want produced. And we get twice as many moles of H2O produced than we have oxygen reacting. Right, that's what the problem told us. So to find the number of moles of oxygen I need, I can just divide by 2. And that'll give us 13.88 if I'm rounding. Leave the value in your calculator though, don't round until the end. All right, now I need to account for the amount that's lost in the reaction. So we have 13.88 moles of O2, and we know that we're not getting 100% yield here. So if we divide this by 0.82, 0.82 is the decimal from the percentage, so 82% yield for a reaction, like 0.82. That means we need 16.92 moles of O2 reacting. And now our final step is going to be to convert the moles of oxygen into the mass in grams. So the mass in grams for O2 is going to be the number of moles of O2 times the molar mass of O2. So that's 16.92 moles times 32 grams per mole. And that will give us 541.5 grams of O2 that's needed. And then we're just going to write our final statement to say what we found in this question. So 541.5 grams of O2 is needed to get a final yield of 500 grams water. And there you go.